Hi, I'm Brian Estep. I'm the Senior Software Engineer here at Sierra, and I'm going to demonstrate our meter tuning functionality. Basically, what you see before you is a screen that displays all the most vital inputs and outputs for our InnovaMass flow meter. There's several different sections. Here you see your flow rate section. Quickly gives you the flow rate, the units being used. You can quickly see the velocity in whether it's feet per second or meters per second. That allows you to quickly determine whether you're in spec or not. If you are using insertion meter, you'll see your flow profile value. Output averaging, which allows you to smooth noisy flow signals. Then you see your fluid properties menu, which gives you quick access to the temperature, the pressure, density, viscosity, and the Reynolds number of the current flow rate. You have your sensor output menu. Here you can quickly see the frequency being measured by your sensor, the amplitude, the gain there. And then you have your sensor tuning section, and this is a very important and will often be used. Basically, you have your minimum noise level here, and what this value is important for is in eliminating environmental noise, 60 hertz signals or something like that coming in from the environment at zero flow that could possibly cause a false flow signal. You want to get rid of that, so you want to use your minimum noise level to do that. Your vortex coefficient, the CK, it's very important. It controls the dynamic frequency filter, which is used to set a window for looking for frequency. Basically, you don't want to look across the entire range of frequency because you could see something very high that might give you a false flow reading. You want to limit it to a certain window. This is how you control that. And then you also have percentage of full scale cutoff if you wanted to use that. So I'm going to go through a few quick scenarios of how you might apply this functionality in the field. We are currently at zero flow, yet we're detecting a frequency of 60 hertz, and it gives us an equivalent amplitude and gain. We're seeing a flow signal. We should not be seeing a flow signal at zero flow, but this is because of this external noise that the sensor is picking up, and it's seeing that as flow. So we have a function to handle that. Basically, the minimum noise level is a cutoff that you use to say below this noise level, do not show flow. So the way you can apply this functionality is in this situation right now. You got your flow rate of 350 gallons a minute. We don't want to see that because we're at zero flow. So the way you would handle that is you click this auto set button right here. And when you do that, what it does is it looks at the current gain and amplitude and determines the value for minimum noise level that is required to cut that noise out, to cut that flow value off. So watch this. I'm going to auto set. It comes up with a value of 11.25, and our flow is now eliminated. I can prove it to you if we go back down to a lower number, say 5. The flow immediately comes back. If I auto set again, our flow is eliminated. That's how the minimum noise level works.
Thank you, Brian. That was terrific.
Yes.
What a neat feature. I think it's just going to come in handy because you don't have to search anymore. The current way we use it.
You don't need. I'm not going to be having to fly around with the magnet.
Yeah.
A couple things on this screen I want everybody to take a look at. The minimum noise level, that is the same functionality that the low flow cutoff in the current version is. So that's where you're going to go into fine tune in terms of the low end. The other nice thing about this that I love is everything is on one screen. So if you make adjustments to see if you can bring in flow rate, you can see it right there up there on the flow rate screen. Where currently, if I make an adjustment, what do you have to do? You've got to go all the way back out again, see what it looks like, and then enter 16363 in again and go all the way back in, make another small adjustment and go all the way back. There's a lot of back and forth. This is all on one screen. And of course,
one button.
One button.
Push one, or put whatever value you want in there.
All of these things are available through the display.
Good point.
But I'm just going to have it hooked up to my laptop computer when I'm in the field working with it. More times than not, you can do that, and then everything can be taken care of at one time with that. So that's a great functionality of having it all in one screen. You make adjustments, you see what the result of that adjustment is immediately.
Right.
That is going to that's going to speed up the process tremendously. So
Right.
so
Excellent.
it's I love this meter tuning screen. So.